The circadian rhythm is not just a sleep-wake pattern, it's the central timing mechanism that governs nearly every process in the human body, including metabolism. Every cell, organ, and tissue follows a daily rhythm that aligns with the 24-hour light-dark cycle of the Earth. This internal clock ensures that biological functions occur at the right time of day, when the body is best prepared to handle them. When this rhythm runs in harmony with the natural environment, metabolism operates efficiently, energy is well regulated, and recovery processes function optimally. But when this rhythm is disrupted, whether through poor sleep, irregular light exposure, or erratic eating patterns, metabolic efficiency deteriorates. What most people don't realize is that the circadian rhythm doesn't just influence when we feel sleepy or awake. It dictates when hormones are secreted, when our body burns fat or stores it, and when our organs are most active in processing nutrients. At the core of this rhythm lies a small structure in the brain known as the suprachiasmatic nucleus, or SCN. Located in the hypothalamus, it acts as the body's master clock. This master clock receives direct input from the eyes and uses light signals to synchronize our internal time with the external world. But it doesn't work alone. Every organ, the liver, pancreas, heart, muscles, has its own local clock, which coordinates daily activity based on signals from the SCN and from behaviors such as eating and sleeping. Together, these clocks form a complex system that ensures all physiological processes are aligned. For instance, in the early morning, the body anticipates wakefulness by raising cortisol levels, increasing body temperature, and boosting glucose availability. In the evening, it does the opposite, lowering metabolism, reducing core temperature, and preparing the body for rest. This rhythmic pattern is what keeps energy balance and metabolic processes in check. When the circadian rhythm is synchronized, metabolic function reaches peak efficiency. Insulin sensitivity is highest in the morning, meaning the body can handle carbohydrates more effectively early in the day. Digestion, nutrient absorption, and energy utilization are all optimized during daylight hours when the body expects food intake. During nighttime, metabolic activity naturally slows, the liver shifts to repair mode, and insulin sensitivity drops. Eating or being exposed to bright light during this period can send mixed signals to the body's internal clocks, leading to metabolic confusion. Over time, this mismatch can result in insulin resistance, weight gain, and hormonal imbalance. In other words, a misaligned circadian rhythm makes the body behave as if it's constantly jet lagged, operating in one time zone while living in another. The relationship between circadian rhythm and metabolism becomes even clearer when we consider how timing influences hormone secretion. Hormones like melatonin, cortisol, insulin, leptin, and ghrelin follow precise daily cycles. Melatonin rises at night to initiate sleep, while cortisol peaks in the morning to promote alertness and mobilize energy. Leptin and ghrelin, the hormones that regulate hunger and satiety, also fluctuate based on the clock. When sleep and light exposure are regular, these hormone rhythms become erratic, leading to increased hunger, reduced satiety, and impaired glucose regulation. Studies show that people with disrupted circadian rhythms, such as shift workers, have higher rates of obesity, diabetes, and metabolic syndrome, even when controlling for diet and exercise. This underscores that maintaining a regular rhythm is not simply about discipline, it's about biology. Modern life, unfortunately, is designed to disrupt these natural cycles. Artificial light extends our day far beyond sunset, suppressing melatonin production and confusing the body about when to rest. Irregular meal timing, especially late night eating, further desynchronizes the peripheral clocks in the liver and pancreas, impairing glucose control and fat metabolism. Add in inconsistent sleep schedules and chronic stress, and you have the perfect recipe for metabolic dysfunction. The body's clocks lose coordination, and what was once a beautifully synchronized system becomes chaotic. Over time, this chaos manifests as fatigue, weight gain, poor insulin response, and slower recovery, not because of a lack of effort, but because the timing mechanisms that guide metabolism have gone off track. Realigning the circadian rhythm can restore metabolic balance more effectively than many realize. Simple behaviors such as getting sunlight exposure within the first hour after waking, maintaining consistent sleep and wake times, avoiding bright light at night, and eating within a defined daytime window help reset the body's internal clocks. These signals tell the brain and organs when to be active and when to recover. Light exposure anchors the central clock, while consistent meal timing reinforces the peripheral ones. The result is a more stable metabolism, improved energy levels, and enhanced hormonal regulation. When your internal timing is aligned, the same diet and exercise routine suddenly become more effective because your body is functioning in the biological window it was designed for. In essence, the circadian rhythm is the silent conductor of your metabolic orchestra. When it plays in tune, every system, from your hormones to your mitochondria, performs harmoniously. But when it's disrupted, the entire composition falls apart. Understanding and respecting this rhythm isn't an abstract wellness concept. It's a foundational principle of metabolic health. It dictates how efficiently you convert food into energy, how well you sleep, and how resilient your body is to stress. The key isn't to do more, but to do things at the right time in alignment with the rhythm nature built into you. Light is not just something we see, it is the most fundamental cue that tells our biology what time it is. Deep within the brain, a small cluster of neurons called the suprachiasmatic nucleus, or SCN, acts as the body's master clock. This structure sits in the hypothalamus, just above the optic chiasm, and receives direct input from the eyes through specialized light-sensitive cells. These cells don't detect shapes or colors, but instead sense brightness, particularly blue light in the morning spectrum. When light hits the retina after waking, it triggers a cascade of signals that tell the SCN it's daytime. The SCN then synchronizes nearly every other clock in the body, in the liver, pancreas, gut, and muscles, ensuring that your metabolism, hormones, and energy systems all run on time. Morning light is like hitting the reset button for your entire physiology, establishing the rhythm that determines when you feel alert, when you get hungry, and when your body expects to rest. When this light signal arrives at the right time, early in the day, it triggers the release of cortisol, the hormone that promotes wakefulness, alertness, and energy mobilization. It also suppresses melatonin, the hormone responsible for inducing sleep. This combination of rising cortisol and falling melatonin is what gives you that natural sense of readiness to start the day. Metabolic activity begins to ramp up, body temperature rises, and insulin sensitivity improves. This is why eating breakfast or engaging in physical activity soon after morning light exposure feels easier and more effective. The body cells are primed to take in nutrients, produce energy, and handle stress efficiently. The natural light-dark cycle evolved to match our internal metabolic cycles, ensuring that we burn energy when the sun is up and repair and recover when it is down. But the human environment has changed drastically. Artificial lighting screens and indoor lifestyles have made it easy to live under constant, irregular light exposure. We wake up to dim indoor light and spend our days under artificial bulbs that are far weaker than sunlight, then expose ourselves to bright blue light from phones and TVs late into the night. This pattern sends conflicting signals to the SCN. The brain struggles to distinguish day from night, and the body's internal rhythms begin to drift out of sync. When you are exposed to light late in the evening, particularly blue light, melatonin release is delayed. You might still fall asleep, but the quality of your sleep diminishes, the deep restorative stages are shortened, and your metabolic rate doesn't reset properly. This disruption in the light-dark signaling cascade leads to hormonal imbalance, impaired glucose control, and altered hunger cues. Over time, this desynchronization can push the body toward insulin resistance and chronic metabolic dysfunction. The timing of light exposure is as critical as its intensity. Morning light exposure within the first hour after waking reinforces a strong circadian signal. It sets the internal clock to start counting roughly 16 hours until melatonin secretion begins again at night. On the other hand, exposure to bright light at 10 p.m. resets that countdown as if it were morning again, confusing the system and delaying sleep onset. Even the quality of light matters. Sunlight provides the full spectrum that the brain evolved to recognize, while most artificial lights emit narrow, unbalanced wavelengths that fail to produce the same synchronizing effect. The modern human spending 90% of life indoors is effectively underexposed to the morning cues that signal activity and overexposed to the nighttime cues that signal wakefulness. The timing of food intake is one of the most underappreciated yet powerful factors influencing metabolic health. The body doesn't just respond to what you eat, it responds to when you eat. Every organ involved in digestion and energy metabolism, the liver, pancreas, gut, and even skeletal muscles, operates on an internal clock that syncs with the body's master circadian rhythm. These peripheral clocks anticipate nutrient intake during daylight hours when the body is naturally prepared to metabolize energy efficiently. Eating at irregular times, especially late at night, disrupts this synchrony. The result is a miscommunication between your brain's master clock, which takes cues from light, and your metabolic clocks, which take cues from food. When these signals are misaligned, the body's ability to regulate glucose, lipids, and hormones becomes impaired, leading to insulin resistance and fat accumulation over time. When you eat a meal during the day, your pancreas is primed to release insulin effectively, and your liver is ready to process nutrients. Your muscles are more insulin sensitive, allowing them to take up glucose efficiently for energy. This daytime eating pattern supports stable blood sugar and optimal energy utilization. However, as evening approaches, insulin sensitivity naturally declines. This is a built-in feature of human biology meant to conserve energy during the resting phase of the night. Eating large meals late in the evening forces the body to digest and metabolize food when its machinery has already started winding down. The pancreas secretes insulin, but the tissues respond poorly, leading to higher blood sugar levels. The liver, which is supposed to be in repair mode, now has to manage glucose and fat metabolism. This mismatch between food intake and metabolic readiness disrupts the circadian balance and contributes to long-term metabolic dysfunction. Research consistently shows that identical meals eaten at different times of day produce dramatically different metabolic outcomes. In one controlled study, participants who ate their largest meal in the morning had significantly lower insulin and glucose levels throughout the day compared to those who ate the same meal late at night. Even when calorie intake and nutrient composition were identical, late night eaters showed reduced fat oxidation, higher post-meal glucose, and lower energy expenditure. These effects highlight that the body is not a simple calorie in, calorie out machine. It operates within time windows where metabolic efficiency fluctuates. The same food can either support health or harm it, depending on whether it's eaten in alignment with the circadian rhythm. Eating late into the night not only impairs insulin sensitivity, but also disrupts the sleep-wake cycle. Digestion is an active process that raises body temperature and stimulates the sympathetic nervous system, both of which interfere with melatonin secretion and sleep quality. Poor sleep further worsens glucose metabolism, creating a feedback loop of metabolic stress. Over time, this pattern increases the risk of obesity, type 2 diabetes, and other metabolic disorders. Shift workers provide a clear example of this phenomenon. They often eat during nighttime hours when their internal clocks are set for rest, leading to chronic circadian misalignment and significantly higher rates of metabolic disease, even when total calorie consumption is similar to day workers. It's not just nighttime eating that matters. Irregular eating patterns throughout the day can also desynchronize the body's metabolic clocks. Grazing or snacking continuously sends inconsistent signals to the liver and pancreas, preventing them from establishing a stable rhythm of fasting and feeding. In contrast, consistent meal timing reinforces metabolic predictability. The body learns when to expect food, and enzymes involved in digestion and energy conversion begin to rise in anticipation. This synchronization allows for more efficient nutrient processing and hormonal regulation. Yeah. Over time, this kind of structured eating pattern supports better metabolic health, improved energy balance, and even cognitive performance as the brain also follows rhythmic nutrient utilization cycles. The growing field of cron nutrition has revealed that metabolic health improves when food intake is confined to a specific daytime window, ideally aligning with daylight hours. Studies on time-restricted feeding, where all meals are consumed within 8 to 10 hours, show improvements in insulin sensitivity, lipid metabolism, and mitochondrial efficiency, even without calorie restriction. This approach allows for long fasting periods overnight, giving the liver time to repair, clear toxins, and restore glycogen balance. It also aligns with natural hormonal rhythms. Cortisol peaks in the morning to promote energy mobilization, while melatonin rises at night to promote rest. Eating within the daylight window supports these natural hormonal shifts, while nighttime eating counteracts them. Practical strategies for aligning meal timing with circadian rhythms are simple but impactful. Having your first meal 1 to 2 hours after sunrise and finishing your last meal at least 3 hours before bedtime keeps your feeding window in sync with the body's biological day. This approach supports better glucose control, enhances fat oxidation, and promotes restorative sleep. Light exposure during the day and darkness at night further reinforce these rhythms, amplifying the benefits of proper meal timing. When these cues, light and food, are consistent, the body's internal clock stays synchronized, metabolism becomes more efficient, and the risk of metabolic disease decreases dramatically. In the modern world, where convenience often overrides biology, eating whenever we want seems harmless. But our metabolism is not designed for constant irregular intake. It evolved under predictable cycles of feeding and fasting that match the rising and setting of the sun. Reclaiming that natural pattern, aligning food intake with the day's light cycle, restores metabolic harmony and ensures that the body's energy systems work with precision and efficiency. The timing of food is therefore not just a lifestyle choice, it is a biological necessity for maintaining metabolic health. The consequences extend directly to metabolism. When the circadian system is misaligned, the body's energy regulation falters. Cortisol remains elevated late in the evening, which promotes glucose production in the liver and prevents proper fat burning during sleep. Insulin sensitivity, which should decline at night to promote rest, becomes erratic. The result is an increased likelihood of storing fat rather than burning it. Studies have shown that people exposed to light at night have higher fasting glucose levels, greater body mass, and poorer metabolic flexibility, even when they maintain the same calorie intake. Light exposure is not just a visual experience. It is a metabolic signal that tells your body when to use or conserve energy. Fortunately, the solution is simple but profound. Regular exposure to bright natural light in the morning can reestablish rhythm and restore hormonal balance. Just 10 to 20 minutes of sunlight exposure soon after waking can reset the SCN and synchronize peripheral clocks throughout the body. Similarly, reducing artificial light exposure in the evening allows melatonin to rise naturally, promoting better sleep and metabolic recovery. Dimming indoor lights after sunset using warm toned lighting and avoiding screens before bed all reinforce the body's recognition of nighttime. The difference in energy, mood, and metabolic health becomes noticeable within days because the body's timing systems respond rapidly to consistent cues. Light is, in essence, the master regulator of human metabolism. It tells every organ when to work and when to rest. Morning light drives alertness and energy production, while evening darkness signals repair and restoration. In the modern world, learning to live in alignment with natural light cycles is one of the most powerful and underappreciated interventions for improving metabolic health. Light is information, and timing is the language through which your body interprets it. When the timing of our daily behaviors, sleep, light exposure, and eating, falls out of sync with the body's internal clock, a condition known as circadian misalignment occurs. This misalignment is more than a simple inconvenience. It has profound effects on metabolic health. The human body is built to operate on a 24-hour rhythm with physiological processes following predictable cycles of activity and rest. Hormones, enzymes, and metabolic pathways are synchronized to ensure energy is used efficiently during the day and conserved at night. When this rhythm is disrupted, the entire system becomes confused. The brain might believe it's daytime while the liver and pancreas are operating in night mode. This internal chaos translates into metabolic inefficiency, insulin resistance, and inflammation. The mismatch between biological time and behavioral time is increasingly common in modern society, particularly with the rise of artificial light, shift work, late night eating, and irregular sleep schedules. At the core of circadian misalignment lies the disruption of hormonal balance. Cortisol, melatonin, insulin, and growth hormone all follow rhythmic patterns that depend on consistent light, dark exposure, and sleep-wake timing. Normally, cortisol peaks in the morning to help the body wake up and mobilize energy, while melatonin rises at night to signal rest. When light exposure occurs at inappropriate times, such as late at night, melatonin release is suppressed and cortisol remains elevated. This prolonged cortisol activity raises blood glucose levels and increases insulin demand. Over time, the cells become less responsive to insulin, forcing the pancreas to produce more of it. This persistent elevation of insulin and glucose creates the groundwork for insulin resistance, the underlying defect in type 2 diabetes and metabolic syndrome. Even short-term sleep deprivation or jet lag can trigger measurable changes in insulin sensitivity, demonstrating how tightly metabolism is linked to circadian stability. Inflammation is another direct consequence of circadian misalignment. The immune system operates rhythmically as well, with specific times of day dedicated to surveillance, repair, and recovery. When the rhythm is disturbed, inflammatory pathways remain chronically activated. This low-grade inflammation interferes with insulin signaling and damages the endothelial lining of blood vessels, setting the stage for cardiovascular disease. Studies have shown that people who work rotating night shifts have significantly higher markers of inflammation and oxidative stress than those who follow a consistent day schedule. These individuals also exhibit elevated triglycerides, higher blood pressure, and greater abdominal fat deposition, hallmarks of metabolic dysfunction driven by circadian disruption. The immune system, metabolism, and hormonal systems are intricately linked. When one goes off schedule, the others follow. Food timing plays a central role in maintaining or breaking circadian alignment. The digestive organs and metabolic enzymes operate on schedules synchronized with daytime activity. When food is consumed late at night, the liver and pancreas are forced to perform metabolic tasks at a time they are least prepared for them. Insulin secretion becomes inefficient, and glucose levels stay elevated longer after meals. The body's capacity to process fats also diminishes at night, leading to increased fat storage. Repeated exposure to this pattern reprograms metabolic pathways, promoting weight gain even without an increase in calorie intake. This is why individuals who habitually eat late or snack before bed often experience gradual weight gain and worsening metabolic health over time, despite maintaining similar diets to early eaters. Sleep disruption compounds these effects by altering appetite-regulating hormones such as leptin and ghrelin. Leptin, which signals satiety, decreases with insufficient sleep, while ghrelin, which triggers hunger, increases. The result is a heightened drive to eat high-calorie, carbohydrate-rich foods, often at times when the body's metabolic machinery is least capable of handling them. This vicious cycle, poor sleep leading to poor eating behavior and further metabolic disruption, illustrates how deeply circadian alignment influences everyday health decisions and outcomes. It also explains why sleep deprivation and irregular schedules are now recognized as independent risk factors for obesity and diabetes. The biological cost of circadian misalignment extends beyond metabolism and body composition. Mitochondria, the cellular powerhouses responsible for energy production, also function rhythmically. Their efficiency varies across the 24-hour cycle, peaking during active daylight hours and diminishing at night. When metabolic activities are forced to occur during the biological night, mitochondrial function declines, leading to less efficient energy use and greater production of reactive oxygen species. This oxidative stress accelerates cellular aging and contributes to chronic inflammation. Over years, this state of biological confusion accelerates metabolic decline and increases vulnerability to chronic diseases such as hypertension, atherosclerosis, and neurodegeneration. The evidence supporting the connection between circadian misalignment and metabolic disease is now overwhelming. Controlled studies show that even a few days of eating and sleeping out of sync with one's circadian rhythm can reduce insulin sensitivity by 20 to 30%. People who routinely experience this misalignment, such as night shift workers or frequent travelers crossing time zones, display higher rates of metabolic syndrome, cardiovascular disease, and certain cancers. This risk persists even after controlling for other lifestyle factors like diet, exercise, and smoking, which highlights the independent role of timing as a biological variable. Realigning the circadian rhythm begins with restoring consistency in behavior. Exposure to bright natural light in the morning, dimming artificial light in the evening, maintaining regular sleep schedules, and restricting food intake to daytime hours help synchronize the body's clocks. Each of these cues reinforces the brain's understanding of time, reducing internal conflict between systems. In doing so, inflammation decreases, insulin sensitivity improves, and metabolic processes regain efficiency. The body thrives when its internal timing is respected, operating as a coordinated whole rather than a collection of disconnected parts. Time-restricted feeding has emerged as one of the most effective ways to restore balance to the body's internal clocks and improve metabolic health. It is based on the understanding that the timing of food intake influences metabolism as much as the quantity or quality of food. The human body evolved to eat during the daylight hours and rest during the night. Every organ involved in metabolism, the liver, pancreas, gut, and muscles, operates on a circadian rhythm. These organs anticipate when nutrients will arrive and adjust enzyme activity, hormone release, and energy utilization accordingly. When food is consumed during the active phase of this rhythm, metabolism functions efficiently, but when eating extends into the biological night, the body's ability to manage glucose and fat deteriorates. Time-restricted feeding, or TRF, seeks to realign eating patterns with natural circadian rhythms by limiting food intake to a consistent daily window, usually between 8 and 10 hours. The power of time-restricted feeding lies in its ability to reinforce internal synchronization between the body's central clock in the brain and the peripheral clocks in metabolic organs. The central clock, located in the suprachiasmatic nucleus, responds to light, while peripheral clocks respond primarily to feeding cues. When eating patterns are erratic or extend late into the evening, these clocks fall out of sync, leading to metabolic confusion. By eating within a fixed daytime window, both sets of clocks can align, optimizing energy use, nutrient processing, and hormonal balance. Unlike traditional calorie restriction, which focuses on reducing energy intake, TRF leverages the biology of timing. It does not necessarily require cutting calories, but rather respecting when the body is best suited to handle them. Several studies have demonstrated the profound metabolic effects of aligning food intake with circadian rhythms. In one trial, individuals who ate all their meals within an 8-hour window during daylight hours showed improved insulin sensitivity, lower fasting glucose, and reduced blood pressure, even though their total calorie intake did not change. Another study found that limiting food intake to a 10-hour window led to reduced body fat and better cholesterol profiles. The key insight from this research is that the body's metabolic machinery is most active during the day, and forcing it to process nutrients at night disrupts natural cycle. Insulin sensitivity peaks in the morning and declines gradually through the day. Eating late in the evening, when insulin sensitivity is low, leads to higher post-meal glucose levels and promotes fat storage. TRF minimizes this problem by confining meals to the hours when the body can efficiently metabolize them. Beyond glucose control, time-restricted feeding also improves mitochondrial function and energy efficiency. During the fasting period, when no food is consumed, the body shifts from glucose metabolism to fat oxidation, promoting metabolic flexibility. This switch allows the mitochondria to repair and rejuvenate, reducing oxidative stress and inflammation. Extended overnight fasting triggers autophagy, the body's internal cleanup process, which removes damaged cellular components and improves tissue health. These processes are critical for longevity and metabolic resilience. The simple act of allowing a prolonged fasting window each night gives the body the opportunity to recover from the constant influx of nutrients that typifies modern eating habits. Hormonal regulation is another area where TRF shows measurable benefits. By maintaining a consistent feeding window, levels of cortisol, melatonin, leptin, and ghrelin begin to stabilize. Cortisol naturally rises in the morning to mobilize energy, and eating during this period aligns with the body's readiness for food intake. Melatonin, which rises in the evening, signals the body to slow down metabolic activity and prepare for rest. Eating after melatonin has begun to rise confuses these signals, leading to poor glucose tolerance and disrupted sleep. TRF respects these hormonal cycles by ensuring that eating stops before melatonin production begins, allowing the body to transition smoothly into its nocturnal restorative phase. Leptin and ghrelin, the hormones that regulate hunger and satiety, also follow circadian patterns and become more stable with consistent meal timing, reducing overeating and cravings. Time-restricted feeding is not a diet, but a framework for metabolic alignment. It can be practiced flexibly depending on individual schedules, but the principles remain the same. Start eating within an hour or two of waking, finish meals several hours before bedtime, and keep the total feeding period within 8 to 10 hours. This approach naturally reduces late night snacking, which is one of the biggest drivers of metabolic disruption. For most people, eating between 8 a.m. and 6 p.m. or 10 a.m. and 8 p.m. provides a balanced window that supports both social and biological needs. Over time, this pattern retrains the body to expect food at specific times, improving digestive efficiency, energy balance, and metabolic health. The broader implications of time-restricted feeding extend beyond weight management. Studies show improvements in blood lipid profiles, reductions in oxidative stress, and better regulation of inflammatory markers. Participants in TRF protocols often report enhanced mental clarity, improved mood, and better sleep quality, all of which are signs of restored circadian alignment. This demonstrates that metabolism is not isolated from other systems. It is tightly linked to brain function, hormonal balance, and cellular health. By eating in rhythm with the body's natural timing systems, we create a state of biological harmony where energy production, repair, and recovery occur seamlessly. The simplicity of TRF is part of its strength. It requires no calorie counting, no specific food restrictions, and no elaborate planning, just awareness of timing. The results come not from eating less, but from eating smarter, in tune with the body's natural design. By respecting the ancient rhythm that governs all living organisms, time-restricted feeding allows metabolism to work as it was intended, efficiently and predictably, leading to improved health, longevity, and resilience. Time-restricted feeding has emerged as one of the most effective ways to restore balance to the body's internal clocks and improve metabolic health. It is based on the understanding that the timing of food intake influences metabolism as much as the quantity or quality of food. The human body evolved to eat during the daylight hours and rest during the night. Every organ involved in metabolism, the liver, pancreas, gut, and muscles, operates on a circadian rhythm. These organs anticipate when nutrients will arrive and adjust enzyme activity, hormone release, and energy utilization accordingly. When food is consumed during the active phase of this rhythm, metabolism functions efficiently, but when eating extends into the biological night, the body's ability to manage glucose and fat deteriorates. Time-restricted feeding, or TRF, seeks to realign eating patterns with natural circadian rhythms by limiting food intake to a consistent daily window, usually between 8 and 10 hours. The power of time-restricted feeding lies in its ability to reinforce internal synchronization between the body's central clock in the brain and the peripheral clocks in metabolic organs. The central clock, located in the suprachiasmatic nucleus, responds to light, while peripheral clocks respond primarily to feeding cues. When eating patterns are erratic or extend late into the evening, these clocks fall out of sync, leading to metabolic confusion. By eating within a fixed daytime window, both sets of clocks can align, optimizing energy use, nutrient processing, and hormonal balance. Unlike traditional calorie restriction, which focuses on reducing energy intake, TRF leverages the biology of timing. It does not necessarily require cutting calories, but rather respecting when the body is best suited to handle them. Several studies have demonstrated the profound metabolic effects of aligning food intake with circadian rhythms. In one trial, individuals who ate all their meals within an 8-hour window during daylight hours showed improved insulin sensitivity, lower fasting glucose, and reduced blood pressure, even though their total calorie intake did not change. Another study found that limiting food intake to a 10-hour window led to reduced body fat and better cholesterol profiles. The key insight from this research is that the body's metabolic machinery is most active during the day, and forcing it to process nutrients at night disrupts its natural cycle. Insulin sensitivity peaks in the morning and declines gradually through the day. Eating late in the evening, when insulin sensitivity is low, leads to higher post-meal glucose levels and promotes fat storage. TRF minimizes this problem by confining meals to the hours when the body can efficiently metabolize them. Beyond glucose control, time-restricted feeding also improves mitochondrial function and energy efficiency. During the fasting period, when no food is consumed, the body shifts from glucose metabolism to fat oxidation, promoting metabolic flexibility. This switch allows the mitochondria to repair and rejuvenate, reducing oxidative stress and inflammation. Extended overnight fasting triggers autophagy, the body's internal cleanup process, which removes damaged cellular components and improves tissue health. These processes are critical for longevity and metabolic resilience. The simple act of allowing a prolonged fasting window each night gives the body the opportunity to recover from the constant influx of nutrients that typifies modern eating habits. Hormonal regulation is another area where TRF shows measurable benefits. By maintaining a consistent feeding window, levels of cortisol, melatonin, leptin, and ghrelin begin to stabilize. Cortisol naturally rises in the morning to mobilize energy, and eating during this period aligns with the body's readiness for food intake. Melatonin, which rises in the evening, signals the body to slow down metabolic activity and prepare for rest. Eating after melatonin has begun to rise confuses these signals, leading to poor glucose tolerance and disrupted sleep. TRF respects these hormonal cycles by ensuring that eating stops before melatonin production begins, allowing the body to transition smoothly into its nocturnal restorative phase. Leptin and ghrelin, the hormones that regulate hunger and satiety, also follow circadian patterns and become more stable with consistent meal timing, reducing overeating and cravings. Time-restricted feeding is not a diet, but a framework for metabolic alignment. It can be practiced flexibly depending on individual schedules, but the principles remain the same. Start eating within an hour or two of waking, finish meals several hours before bedtime, and keep the total feeding period within 8 to 10 hours. This approach naturally reduces late night snacking, which is one of the biggest drivers of metabolic disruption. For most people, eating between 8 a.m. and 6 p.m. or 10 a.m. and 8 p.m. provides a balanced window that's of both social and biological needs. Over time, this pattern retrains the body to expect food at specific times, improving digestive efficiency, energy balance, and metabolic health. The broader implications of time-restricted feeding extend beyond weight management. Studies show improvements in blood lipid profiles, reductions in oxidative stress, and better regulation of inflammatory markers. Participants in TRF protocols often report enhanced mental clarity, improved mood, and better sleep quality, all of which are signs of restored circadian alignment. This demonstrates that metabolism is not isolated from other systems. It is tightly linked to brain function, hormonal balance, and cellular health. By eating in rhythm with the body's natural timing systems, we create a state of biological harmony where energy production, repair, and recovery occur seamlessly. The simplicity of TRF is part of its strength. It requires no calorie counting, no specific food restrictions, and no elaborate planning, just awareness of timing. The results come not from eating less, but from eating smarter, in tune with the body's natural design. By respecting the ancient rhythm that governs all living organisms, time-restricted feeding allows metabolism to work as it was intended, efficiently and predictably, leading to improved health, longevity, and resilience. Aligning light exposure, sleep patterns, and meal timing is one of the most fundamental yet overlooked practices for optimizing health and metabolism. The human body evolved in harmony with the planet's 24-hour light-dark cycle, and every biological system, from hormone release to digestion, depends on that rhythm. When these environmental cues are consistent and synchronized, the body functions with precision. When they are inconsistent or mismatched, the internal clocks that regulate metabolism begin to drift out of sync. This desynchronization leads to reduced energy efficiency, poor sleep, impaired insulin sensitivity, and hormonal imbalances. Modern lifestyles filled with artificial light, irregular sleep, and around the clock eating have gradually disconnected us from these natural rhythms, creating a silent epidemic of circadian disruption. Realigning these cues, light sleep and meals, restores the body's innate order and promotes long-term metabolic balance. Light is the most powerful signal for setting the body's internal clock. Early morning sunlight exposure triggers a cascade of biological events that prepare the body for activity. Light enters through the eyes and stimulates the suprachiasmatic nucleus in the brain, signaling that it is daytime. This suppresses melatonin, increases cortisol and alertness, and initiates the daily rhythm of metabolic activity. Morning light exposure also sets a timer that determines when melatonin will rise again in the evening, helping to establish a consistent sleep-wake cycle. Without this anchor, the body loses track of time, leading to grogginess in the morning, alertness at night, and irregular appetite patterns. To keep the circadian rhythm in sync, it's essential to get bright light exposure within the first hour of waking, preferably from natural sunlight. Artificial light indoors is too weak to have the same effect, and missing this signal means the day's biological clock starts late, throwing off everything that follows. Evening light exposure is equally influential, but in the opposite direction. Bright, blue, enriched light at night delays melatonin release, keeping the brain in a state of artificial daylight. This suppresses sleepiness, disrupts deep sleep, and confuses metabolic processes that rely on darkness to function properly. The liver and pancreas, for instance, are supposed to rest and repair at night, But exposure to light, even from screens or overhead bulbs, tells the body it's still daytime. This misalignment affects glucose regulation, making late night eating particularly harmful. Dimming indoor lights and avoiding screen exposure 2 hours before bed sends a clear signal that it's nighttime, allowing melatonin to rise naturally and metabolic systems to shift into recovery mode. Sleep itself is the second pillar of circadian alignment. Quality sleep is not just about duration, but about timing and consistency. The body's ability to repair tissues, regulate hormones, and balance blood sugar is tightly linked to the sleep-wake cycle. Going to bed and waking up at roughly the same time each day trains the internal clock to operate predictably. Inconsistent sleep schedules, even by an hour or two, can disrupt hormone secretion patterns. Cortisol, insulin, leptin, and ghrelin all depend on consistent sleep timing to maintain their natural oscillations. When sleep is irregular, cortisol remains elevated in the evening, insulin sensitivity drops, and appetite hormones become imbalanced, leading to cravings and poor energy regulation the next day. Deep sleep, which is most restorative, occurs predominantly in the early part of the night, meaning that going to bed too late can shorten this vital phase, even if total sleep duration is adequate. The third pillar, meal timing, works in concert with light and sleep. The digestive system, liver, and pancreas are governed by peripheral clocks that respond to food intake. Eating at consistent times reinforces the signals from the central clock in the brain, helping to maintain overall circadian coherence. Ideally, food intake should align with daylight hours when the body is metabolically active. Finishing the last meal at least 3 hours before bed allows the body to complete digestion before sleep, improving metabolic efficiency and sleep quality. Late night meals force the body to continue processing nutrients during the biological night, impairing glucose tolerance and fat metabolism. Aligning meals with natural light cycles early in the day rather than late supports energy production during waking hours and recovery during sleep. Temperature and physical activity also play subtle but important roles in maintaining circadian rhythm. Core body temperature naturally rises during the day and falls at night to signal readiness for sleep. Regular daytime activity strengthens this temperature rhythm and reinforces wakefulness. Exercise early in the day or afternoon aligns well with this pattern, while intense late night workouts can delay the drop in temperature and disrupt sleep onset. Keeping the bedroom cool at night further enhances melatonin production and improves sleep quality. These environmental and behavioral cues collectively shape how the body interprets time. Realigning light, sleep, and meal timing does not require dramatic lifestyle changes. It requires consistency. Waking at the same time each morning, getting sunlight early, eating within a defined daytime window, limiting evening light, and maintaining regular sleep patterns create powerful feedback loops that reinforce circadian stability. Within a few days of consistent behavior, people often notice improved energy, sharper focus, and better sleep. Over weeks, measurable changes occur in insulin sensitivity, blood pressure, and metabolic flexibility. The body's natural rhythm, once restored, makes maintaining health effortless rather than forced. When these three cues, light, sleep, and food, are synchronized, the entire system functions as it was designed to. Hormones rise and fall at the right times, metabolism becomes more efficient, and energy levels remain stable throughout the day. In a world filled with artificial stimulation and irregular schedules, returning to this natural alignment is one of the simplest yet most profound strategies for improving overall metabolic health and longevity.